Hi everyone, welcome to our part 2 of our 7.1 notes. So right now we are in the very first section of our chapter 7 notebook, and we're just finishing off where we left off from class, which is on the second to last page here. So we've already talked a little bit about what a quadratic function is. It's a parabola, and we're given this formula in standard form. The equation for a quadratic relation is y is equal to ax squared plus bx plus c, where a, b, and c tell us some information. Okay, a tells us if the parabola opens up or down. Okay, c is the y-intercept, and b here is related to the axis of symmetry. It's not, the value for b is not always the exact same as the axis of symmetry. However, when we change the value of b, we change the location of the axis of symmetry. So for the next few examples, we're going to predict, we're not given the, in every case, we're not given the equation. So we're going to predict what the value of a would be if it's positive or negative. We're going to predict the value of c, okay, the constant, the y-intercept, and we can estimate just from looking at our graph what is the line of symmetry. Okay, the line of symmetry, we also refer to that as the axis of symmetry, and it has a formula: x is equal to some number on the x-axis, and that's going to be a line right through x is equal to, maybe it's 3, maybe it's 4, maybe it's 0, and we can see that that's where it divides our parabola into two equal symmetrical parts. Okay, so let's start off here and have a look at the first one. Right away, I see that this parabola opens up. And so a is going to be greater than 0. A is going to be a positive value. So immediately I can tell that about this parabola. A is going to be a positive value. The next thing I can have a look at is the value of c. Okay, let's figure out what c is. Remember that c is your y-intercept. And so we're looking for where does this parabola cross the y-axis. Sometimes it's helpful just to highlight the y-axis. There's the y-axis right there. And let's see, where does the parabola cross it? Well, the only place it crosses it is right here at the origin. Okay, so there is my value of c. Okay, the parabola crosses the y-axis, okay, at the point 0, 0. Okay, or another way to say that is at the point y is equal to 0. Okay, the coordinate of that point is y equals 0. That tells me that c is equal to 0. So c is equal to 0. Okay, and I can estimate the axis of symmetry by looking at this parabola, and there's a couple of different ways I can do it. I can just eyeball it and say, where is the line of symmetry? Where does this parabola, if I were to put a line in there, where does it divide the parabola into two exactly equal parts? And in this case, when we look at it, we can see that the line of symmetry is actually right along the y-axis. Okay. Another way I could do this is to look at any 2 points that have the same y-coordinate, so 2 points across from each other on the parabola, and say to myself, well, the axis of symmetry is going to be right in the middle of those 2 points. Okay, so in this case, if I look at where is it crossing, it's going right through, on my x-axis, it's going right through x is equal to 0. So my axis of symmetry, let me use a different color here, okay, is right here. Okay, so the axis, or the line of symmetry, has the equation x is equal to 0. Okay, that's the equation of my line of symmetry. Let's do the next one. I see that it's not, the line of symmetry here is not going to be right through 0 on the x-axis. So I can start off by recognizing that this parabola is opening downwards. So I could start off with my value of a. If a parabola opens down, that means that a will be a negative value. So a is less than 0, or in other words, it's going to be a negative value. Okay, let's have a look and see, where does this parabola cross the y-axis? Well, if I look, I see that it crosses the y-axis right here. Okay, so it crosses the y-axis at, well, what's the point? That's the point 0, 6. Okay, in other words, it crosses where y is equal to 6. And so C is equal to, C is always equal to that point on your y-axis where it crosses. So in this case, it's equal to 6. My y-intercept is C equals 6, or the point 0, 6. Okay, finally, let's have a look at our axis of symmetry. Again, you can eyeball it. If you start at the vertex, okay, which is the highest point on this parabola because it opens downwards. If I were to take my ruler and just draw a line right through the center of this, I can eyeball where it's going to cross through the x-axis. Okay, and if I did that, okay, to the best of my ability, with a straight line, I see that it looks like it's crossing through right at x is equal to -1. Okay, x is equal to -1. That's where it crosses, that's where my line of symmetry goes through my x-axis. So that's the equation of the axis of symmetry. So the axis of symmetry is the line x is equal to 1. -1, sorry. A little bit later, we'll actually calculate the axis of symmetry. So right now we're just estimating it by looking at the graph. And if you have a ruler, you should be able to very accurately estimate it. But we will a little bit later find a mathematical way to check the axis of symmetry using 2 points on the parabola. Let's do the last example here in your notes. And here's this parabola. Again, right away, you look and ask yourself, is it opening up or down? This parabola opens up. And so A is going to be greater than 0. A will be positive. Okay. My y-intercept is going to be the place where this parabola crosses my y-axis. And I can see here, again, sometimes it's helpful to highlight your y-axis, or in your mind, just run your finger down it until you see, oh, where's the point where it crosses? Well, it's going to be right here. Okay, there's the point where it crosses. So my y-intercept okay, is the point 0, -4. So C is equal to -4. The y-intercept is -4 here. Sorry, -1. Sorry, you guys. My graph that I'm looking at is a little bit fuzzy. Sorry about that. -1. Okay. And finally, my axis of symmetry, I'm looking at my parabola. And again, you can look for your vertex, which is going to be the lowest point on that parabola. The line of symmetry runs right through that vertex. Okay, so again, I can take my ruler out and draw a nice straight line. Okay, right through that vertex, so right through the parabola. And I can see that it crosses the x-axis at x equals 1, +1. So there is my line, or my axis of symmetry. So the axis of symmetry, okay, the equation of that line is x is equal to +1, just by looking at it. And there's 3 pieces of information I can get immediately, okay, without even knowing what the equation for this parabola is. Great. On our last page here, we're going to have a look at some equations, and we're going to ask ourselves, are these equations quadratic? So remember a couple of things that are very important here. One is that a quadratic in standard form, okay, will look like this. Y is equal to ax squared plus bx plus c, okay, which means the degree has to be 2. In other words, I should see that the greatest exponent, okay, for my x here is 2. And if I see that it's not a quadratic. Okay, we may have to rearrange some of these equations to get them in a standard form so we can confirm that they're quadratics. Okay, so let's go ahead and do that. The first one, y is equal to 3x minus 8. Immediately, I see that the degree is 1. This is not a quadratic. So no. Are these quadratics? No. Okay, this is a linear. relation or a linear equation, a linear function, okay, because the degree is 1. So if I graph this, it's going to be a straight line, definitely not a quadratic. The next one, it's already written for me. If I compare this standard form, okay, to this one over here, I can see that it's in standard form, and I have, there's my A value, okay, there's my B value, and there's my constant, there's my y-intercept, my c value. And I can see that this is in standard form and there is an x squared present. So the degree, the highest exponent is 2. So yes, this is a quadratic. Okay, the next one, immediately looking at it, I might need to rearrange this a little bit, okay, because I see that if I look at it right now, I have the 2x plus 1 squared. I might guess that it's a quadratic because I do see that squared here. So I see that at some point we probably will end up with a degree of 2. Let's go ahead and just expand this and put it in standard form just to confirm. So when I have 2x plus 1 in brackets squared, I can expand that by writing 2x plus 1 multiplied by 2x plus 1. Okay, and then I'll put on that plus 7 as well here. Okay, when I expand this, okay, I have 2 binomials that I'm multiplying together. So I'm going to multiply the first, okay, then the outsides, the insides, and then the last numbers. So I'm going to get 2x multiplied by 2x is 4x squared, okay, plus 2x times 1 is 2x. Okay, now I'm going to multiply my inside numbers. 1 times 2x is going to give me another 2x, and 1 times 1 is just going to give me 1. So I've expanded. Okay, in other words, I've multiplied those 2 binomials together, and now I have that plus 7 that I have to add on to the end. So if I simplify this now, put the like terms together, 1 and 7 are like terms. They can be added together. And 2x and 2x are like terms, so they can be put together as well. And I get 4x squared plus 4x plus 8. Okay, for my equation. This is just given to me in an equation. This can also be equal to y. Okay, it could have also been written as y is equal to 4x plus 4x squared plus 4x plus 8. And I see that the degree is 2, and so this is a quadratic. Yes. Okay, there, I've got another one. The very last one here, let's go ahead again. This is, I see that I have some multiplication to do. So this hasn't been completely simplified. This can also be equal, I'm just going to add equal to y here. Okay, so this is just now it's an equation. 2x, or x times x plus 2 minus 2 is equal to y. And again, let's take care of this x out front of the brackets. Okay, let's multiply through. Okay, this is just a one term in front of a binomial, so let's multiply through or expand. And then after we expand, we'll simplify. And so we get x times x is x squared, okay, plus x times 2. X times 2 is 2x, okay, and we have that minus 2 is equal to y. And when I expand it, I see that the degree is 2. So yes, this is also the quadratic. So out of these 4, 3 of them are quadratic functions. The first one isn't because the degree is not 2. So I'd like you to try some questions now in your textbook on page 360, numbers 1 to 6, and answers are in the back for you to check your work. Thanks for joining me, and good luck.